Hello.
Good morning. Welcome at Release.
Thank you. Hello.
Nice meeting you today.
Thank you.
Hello. Good morning. Good morning. How are you today?
Okay, ladies and gentlemen. First of all, good morning.
Now, what is released today in 2025, I think it's very important to feel the situation, to feel the people, to feel the building. So we are very happy to host you today for this important meeting. It was impossible to have you all together in the building, and now you are with us, really. So welcome.
In the arch, we will circle the indication, and then we have to do either approve or reject as a dentist. So going from 4 indications, where you hover over the arch and you find the indication and then you select them, you have to click either an approve or reject. If I click on approve, the arrow will turn green, and it will propose the other one. And of course, it's all is guided. You have the upper arch, the lower arch, everything is guided. So if I don't want to get this indication, I can reject. It will turn into red, and then I can press it. So now what I did is going from 4 indications to only 1 indication. It's very important because time is money, of course, and you don't have to go over all of this. Everything is done automatically. But of course, you have to approve or reject. One of the most important things is that in the end, it will give you the generated report of the things that we approve and the things that we reject. And as soon as you're done, a summary of all the findings will be separated between upper arch and lower arch with all the indications that has been found.
This is about the scanners. This is about the 3Ds. This is about the scanning town. I really believe this is a very good tool. And nowadays, we do that. Come on. What if we do this type of thing where patient and we add this other information to our armamentarium? Huh? I can tell you, if I'm losing 0 patient nowadays, I'm having more patients because I can show them. And what I do, I also teach my patient this video, showing to them the problems, the solutions, and by seeing that, I'm pretty sure they're going to send those videos to other people so they can see that, and they'll go, this is free advertising. And from the heart, the most important advertising. So I believe, and this is something that I want to discuss with the 3D team here from the team that is developing this software now. You have this thing is going to save a lot of time for relax. Yeah.
Between software to make it easy for the dentist, because for us, 3D is a kind of for care stream. For any company, they want to make it the same, the experience easy for the customers. Or at least
for the people that don't know me, my name is Josh Kikouan. I'm the Group Industrial Design Director, and I'm basically responsible for everything that is visual in this company, from the shape of the scanner to the interface of the software to the website, packaging, all of that. So what is gamification? The idea of gamification is to apply game mechanics to non-game interfaces. And the idea is to, with this, leverage psychology and design to kind of motivate intrinsic motivational factors.
Of course, during this project we learned a lesson, and when we were working on the hardware of OVO3, we made a lot of improvement in the hardware in order to tackle or in order to manage this type of interactions automatically. So OVO3 doesn't have this issue. For example, for the project Scan and Tell 2.0 that my colleague presented earlier, we are currently in this phase where we are validating the final prototypes. And Scan and Tell 2.0 is supposed to detect a lot of anomalies inside the patient's mouth. For example, the decay, the plaque, the gold filling, the gingivitis, the cracks. And so the idea is like to send the scan to the AI, and the AI detects this marginal line properly and with very high accuracy. This was trained on a huge amount of data that we collected as this. For example, for Fly AI, we detected like 45,000 scans, which is a huge amount. Parallel surgery, and of course to do some orthodontic simulation. And we're currently working on partnerships with lot of companies delivered this project. One of them is an American company called Pearl that were last week. So one of the technologies that we tried was the ultrasound. So I guess all of you are familiar with ultrasound. One of the problems with ultrasound is the fact that it has low contrast images, has some noise as well, but it helps visualize what's happening below the gingival. It's like we're talking about the cement-renal junction, alveolar crest, and the periodontal ligaments. And as you can see, the images here, these are low contrast, they have some noise. At some point, and by the way, it's like this topic was, there was some work on ultrasound in the literature, and all the papers that have been published in this domain, they came up with the same conclusion that this required manual navigations. So the idea is to create like a simple combo, or a complex combo actually. We need a 3D scanner with an ultrasound system or any other technology, but we have to start with the ultrasound for the sake of proof of concept, and of course again. So since the ultrasound images are very noisy, here we use AI in order to detect, for example, here you see the alveolar bone, and of course the beginning and the end of the, or the boundary of the cement-renal junction. And since the AI, with every image that we're acquiring or capturing, the AI is going to detect or segment the periodontal ligaments and periodontal details. And again, there is no single device today in the market that does this. And since this device is not, or this system is not with an intraoral scanner, and the intraoral scanner is sweeping inside the patient's mouth, we got to reconstruct the scene. This has never been done, ever, in the market. We have like devices that scan the surface, we have devices that scan the hard tissue, but what's the anatomical layer that's in between? Say it's like the first to tackle it, and the first we get very satisfying result with the help of an AI force. So the ultimate goal is to create a unified 3D dataset. A dataset that has the surface and also the subtendral anatomy. And here where we work on a lot of designs, see one of the designs that gave some recent results. And of course the idea is to enable the scientific boundary detection to detect all these elements that are needed for diagnosis. For example, as you know, it's like if we detect all these periodontal details below the gum, and we can do diagnosis, we can detect if there is like a bone loss, and by the way, bone loss is in the device today because of the vitamin D deficiency and everything that comes with it.